with one. I want you guys to have something to practice for the quizzes on Wednesday as well. And Sherry, hopefully now the quizzes on Wednesday will make a little more sense. Oh, Sherry, sorry, Angie, you asked me the question about it. Hopefully it'll make a little more sense as far as what you have to turn in. So you guys might remember in 243, if you had me for 243, which I know all of you didn't. Oh, need some more? Yes, please grab some more. You might remember this graphic. It was a series.
Oh, that's right.
The Grandel Reporter Gem series. It was released about 5-6 years ago, I think. And they had a number of nations' flags. And the nation's flags were set up in such a way that the people that created the study data mined the nation's statistics or parameters, depending on what you want to call them. It was very early in 243. This was one of them. And if you look and you figure out the actual mathematical areas of the red, white, and blue regions of the flag, those are roughly equivalent to the percentage of red, those who were in favor of the war in Iraq, white, those who were against the war in Iraq, and blue, the ones that couldn't find Iraq on a map. and amazingly enough, they never sourced the results. I didn't check the American ones. I checked the Brazilian one and I checked the Chinese one. They were startlingly accurate, which is cool. I never checked the American one, and I said, you know what? I'm not going to bother checking. We're going to see if it's changed at all. Okay? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 22. That's a cozy sample. You ready? No smartphones. No smartphones. No Googling. Here we go.
Where's Iraq?
Find Iraq. I want to see if your guys' failure to find Iraq rate is any better or worse than the American people in general. This is not to make anybody feel dumb. It's just random sample. Now,
Can you find it?
I did, but I found it 6 years ago when Iraq was in the news. I'm not sure I could find it now that it's not in the news as much. I mean, I'm not sure if you ask me now, and without my prior knowledge, I know where it is just from seeing it over and over and over again 6 years ago. And this often happens. My geography is so freaking awful, and I think that's part of being American. We're so America-centric, you know. I was showing Max a map of Russia yesterday. He's like, yeah, Daddy, we live right here. And I'm like, ooh. You know, because we're on the left side of the United States, and he assumes every body of land is the United States. I'm like, that's so cute. It's so adorable. It's like, no, buddy, that's Siberia. That's where they used to send people to die. It's all good, though. All right, we got it? You got to guess where Iraq is? Who wants to show me with the laser pointer? Tim, go.
Where's the laser?
Big yellow button. Boom! Right there.
That's Iran.
That's Iraq.
And that's Afghanistan.
Saudi Arabia. Right. One of them is Kazakhstan. Which one is that?
There it is right there. Kazakhstan?
Is that right?
Kazakhstan.
Yeah.
That's Mongolia.
Kazakhstan was one of the interesting ones. That was one of the ones that wasn't there before
Sochi, I believe, is
89.
right there.
Sochi's, yeah, pretty far west.
I'm gonna give
Yeah,
this
west.
thing back.
That's okay, thank you. I appreciate the geography lesson. So here, let's collect some data. There's Iraq. There's Iraq. Let's test the inability of us to find it versus the American public, okay? So let's do it. Let's turn this off. I also, if you guys want, I made a little map with a right or wrong on the back. Ask your friends. See if they can find it. Bring your data back to class in a couple weeks. We'll collate it together and get a larger sample. Because right now we have 22. We've got 22, which is not a very big sample. Any computation we're going to do is going to have a very large margin of error on it, yes?
Can we be blue and red? Blue and orange?
Blue and... Oh no, we're just going to do blue. Or, yeah, blue, because blue's the ones that couldn't find Iraq. So what I'm going to do is, I did a little geometry to figure out what that percentage was. It turns out to be 19.7%. You can actually Google the dimensions of a US flag, and there's actually a constitution or some procedures manual for the United States that actually defines what size a star has to be on the flag relative to the flag itself. It's crazy. It's important, I guess. So anyway, let's take a look at this. Yeah, let's be blue, because that's what I was testing, whether or not you could find. I wasn't testing whether you were in favor or against the war, which is now ancient history anyway. I'm just testing to see if you guys could find Iraq, or actually if you guys couldn't find Iraq. Because the idea was blue couldn't find Iraq, right? Exactly, exactly. So let's do P is the percentage of you guys. I'm going to call, when I say you guys, all Math 244 students. You guys are my random sample of Math 244 students who can't find Iraq. You're my very unrandom convenient sample of Math 244 students. Thank you for playing. Now, based on that analysis of that map I did, it's 19.7% of them. Isn't that crazy? Blue is about 20% of that flag. It's kind of fun. What I had to do is I had to figure out the size of the star, multiply it by 50, then figure out the size of the field, subtract the stars out, and what's left is just the blue. Then you just rate it over 100%. There it is, 100%. What do you think? Now, I didn't ask for data yet, so this is us being inferential statisticians. Should we just say we're different to see if we're different, and then we can see if we are different, which way we went?
Yeah, you ask, has it changed?
Has it changed? Not has it gone up or down, but just say it's different. I love that, because that's the best. Honestly, most statisticians like two-tailed tests, because in something like this, you have no idea of knowing where it's going to go. So it's easier just to make it two-tailed. And one of the awesome reasons for making it two-tailed is, it gets it, watch this, mathematically, here's your bell curve. Here's your 19.7% right here. In a two-tailed test, you've actually got to get further to get into that significant region, don't you? Because you got 2.5 here and 2.5 here. You don't know which way it's going to go, so you actually have to go further. Yeah, let's do one of those. Yeah, for sure. We're going to do one more template on this bad boy to finish it out. I think we can do it pretty quickly at this point. So let's set up our region. 2.5%. 2.5%. Let's see. We have no data yet. We have a hypothesis we're testing. The opposite of that would be it's equal. In other words, it hasn't changed significantly from 19.7. Realize, of course, we're going to have a humongous freaking margin of error because there's only 22 of us in here. It's not a very big sample. Okay? Let's skip, just looking at the clock, let's skip the error analysis. I'll have you guys take that home and finish it off and bring it back next time. But let's get right to the meat of the course as far as, so we'll skip 4 and 5. We'll have you guys bring those home and finish them and bring them back next time. And we'll start by chit-chatting about the errors. And let's just go through and do 6, 7, 8, 9, and 10, because that's the part we can get done fairly rapidly from the technology and then the curve. Cool? All right. So let's jump down to 6. Which distribution are we going to be using? I apologize. It's been a very boring question all day. It's always Z right now. I swear to God, we'll change next time. We'll change to T. And then pretty soon we'll change to chi-squared F as well. A couple weeks. We'll change to each of those. Good. So it's definitely going to be a Z distribution. Test statistic and p-value. Now in order to get the test statistic, we got to get some data. You can't do the sausage right up without the sausage. Without, I guess, the meat. So stat tests. We're testing against 19.7%. Very, very good. 19.7%. We know there were 22 of you. Be honest. How many couldn't find Iraq? It's totally fine. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Let's see if that has changed significantly. 8 out of 22. That's like a third-ish, somewhere in that neighborhood. It's about a third, plus or minus a very large margin of error goes to the 22. Everybody following that? We're checking 8 out of 22. Is it okay? Not judgmental. Everybody's looking all sheepish. Not being judgmental. I'm pretty sure I couldn't find it either, except I kind of grew up, if you will, in the early part of my teaching career around all that. So let's draw it. Here we go. 2 tails. Look at this. Kate, your question just appeared. Your question just appeared. Look at that. Look at that. Now, check it out. The thing about a 2-tailed test is, this is a fantastic result, actually. It's a fantastic result. I'm glad you guys are taking this home. I want you to think about it. So we got a test statistic. Your test statistic is almost exactly 2, 1.96, which you might remember from 243 as a very special number, which is the 2 standard deviation cutoff. And you might notice why it's significant over there with the p-value, because the p-value is almost exactly 5%. It's almost exactly 5%. It's squeaked in. Remember what Kate asked about 45 minutes ago? What happens when? What happens when your p-value ends up very close? Now, here's a question. Which side did you guys land on? Of 0. So this is the rate of 19.7%. I didn't get p hat because I didn't run the calculate menu. I ran the draw menu, but you can tell by this where you guys landed. It's positive, which means you guys are over here. You guys are over here, right? You guys are in that land over there. Does that make sense? 1.9651, positive one. That means you guys couldn't find Iraq at a slightly higher rate than 19.7%. Is it statistically significant? Statistically significant. Yes, because that's less than 5%. I'm not saying it's meaningfully or practically significant. I'm saying it's statistically significant. This is your question, Kate, about what happens when it's near 5%. Come back to that. Give me 30 seconds, we'll come back to that. So, we got a very small p-value. Very small means less than 5%. In a study, you'll very often, they probably won't put 4.9, probably will put less than 5. Then your job is to decide how much less than 5. Don't worry about that, you can't answer that question. So, let's finish up number 9. What do you think? It appears or does not appear? It does appear. We're less than 5%. It appears that the percent of you guys who can't find Iraq is different than 19.7%. It appears it's different.
So can you use at a higher rate for
Let's.
different?
I want to answer. This is a great question, which I want to get to it. Just give me a second, JC. Just a second, if you would. Just a second. I want to re-answer Kate's question too. Bless you. There is a mathematical way to proceed from here, and there is also a practical significant way to proceed from here. Let's talk about the mathematical way. Actually, technically you're done. You did the hypothesis test. What type of error could we make? It's definitely a type 1. It's a small p-value. Some of you are shirking me going, it's not really that small. Good. It's not. It's damn close to 5%. I've never had it that close to 5% before in the data collection in class. Yay. Yay us. Here's the deal, though. Here's the deal. If you think that's too close to 5% to be believable, I'm not even saying that you care about this. It's a pseudo-joke statistic put on a very interesting website to kind of comment on the ignorance of Americans in a lot of ways. Totally fine. If you think, though, that you want to contest it, then go collect more data. Watch what happens. Watch what happens if we asked twice as many people but got the exact same percentage result. Because watch this. Check this out. You guys at 36%. That's the percent of those who couldn't find Iraq in the class. 36% of you, right? Suppose we ran the test again. Now watch this. This is interesting. Suppose 16 out of 44 couldn't find Iraq. Isn't that still 36%? Right? It still is. But look at the p-value now. The p-value is 10 times smaller.
So this
Why is the p-value 10 times smaller? Boom! The central limit theorem! Remember, the larger the sample, the smaller the margin of error.
This is why you're sending us to go out solve our.
This is why, if you care, go ask more people. And we'll combine their data with your data and see if we can't get closer to that 44. The other thing that's interesting is we might not stay at 36%. With such a small sample, the fluctuation of that percentage is almost guaranteed. I mean, hell, if every one person we shift in here, that's 5 percentage points, right?
That's why we have to set the limit.
That's why we have it, because the more you get, the closer you get to the true target. But every person in here that flips, they could find Iraq versus they couldn't find Iraq, it's 5 percentage points, right? 20 people, each one is 5% of the total. Kind of interesting, huh? That's why large samples are better, because they have less volatility, more stability. Cool? Make sense? All right, so you guys take that one home with you and do the bit about the error, type 1, type 2, and which one you think is worth. Which one do you want to hand in as far as an in-class? You want to do the Florida Motorcycle Death Rate, the Prevnar, or the other one, the flu? Vote for Prevnar? Prevnar, got 4 or 5 votes for Prevnar. Florida, 6 votes. Florida Motorcycle Death Rate? Only one of them.
I don't understand why it matters.
It doesn't matter, I can make you guys.
We're all.
That's
we all
the only
did
thing
it.
I've got.
Prevnar?
Yeah.
Prevnar it is. And if you want to use Prevnar as an in-class quiz, make sure your name's on it, turn it in, make a little file right here. We'll try to do one of these per day, if we can get to it. I think we probably can.
Or we need to draw a spell.
No, you don't have to. I'm just, you're welcome. I'm gonna start leaving you space for them though, for sure. Because I like having the bell curve up there as kind of a target for shooting for. Yeah, go ahead and make a pile of that. It's beautiful. Yes. Have a great rest of your day.